Hello, I want to welcome Dr. Aditi Sharma, ma'am. She is here with us. Please, everybody, pay attention. Ma'am, I'm giving you the rights of as a co-host. Aditi, just a minute. Yeah. Ma'am, can you hear us? Aditi, ma'am?
Yes, sir. I can hear you.
Okay.
Just a minute. Give me 2 minutes. Yeah.
Yeah, sure, sure.
Yeah.
Good afternoon, everyone. It's my honor to introduce our distinguished guest, Dr. Aditi Sharma, a luminary in field of computer science and engineering. Dr. Sharma has done PhD in same field of MBM Engineering College, JNVU, India in 2018. In a career of 15 years, Dr. Sharma has an associate professor at Symbiosis Institute of Technology, an international university in Pune. Her research extends across various domains including cryptography, blockchain, VLSI, cellular automata, machine learning, AI chatbots, IoT, international artificial intelligence. She has published 65 research papers in esteemed international journals and conferences. Dr. Sharma international exposure includes fellowship at Nazarbayev University, Kazakhstan, focusing on intelligent crypto system, IoT, cloud in robotics. She is also visiting faculty at Astana IT University, Kazakhstan, and University of Oyo, Nigeria, demonstrating her global impact. As a senior member of IEEE and active participant in 5G security group, Dr. Sharma's dedication to advancing technology is evident. She has authored 4 books, published 10 patents, and hold 19 granted patents. Her commitment to academia is further underscored by her roles as a reviewer for prestigious journals like IEEE Transaction on Industrial Informatics and IEEE Transaction on Big Data. Dr. Sharma accolades and achievements are numerous, including Navshakti Award by Northern Eastern University Council, Ministry of Donor, Government of India, Parvati Chanda Devi, and Gargi Scholarship, and awards from distinguished personalities such as Madanlal Khurana, Sunil Dutt, and APJ Abdul Kalam. She has been recipient of Best Teacher Award by Rajasthan Patrika Group, showcasing her commitment to education. Now, I would like to share my now I would like to share mic with Professor Aditi Sharma.
Thank you, ma'am. Thank you, Saurabh sir and the institute to give me the opportunity. And let me start my PPT. Let me present first. Is my screen visible to you?
Yes, ma'am.
Yes,
It
ma'am.
is.
So I have taken a basic topic that how the machine learning is using for the society 4.0. So this is like a sustainable goals aspect of what is AI, machine learning, and deep learning. What is society 4.0, and what kind of application we can deploy for the society for like using other techniques into the machine learning and the deep learning, and what are the challenges. So we have like plotted the 17 sustainable development goals, that is no poverty, zero hunger, good health and well-being. So UN has demonstrated these goals under the like for all the countries where we can develop the solution for all these things. Now the question comes as an engineer or as an academician, how we can come for the society for developing technology revolution to the industry revolution to the society revolution. So that like the smart city framework or cyber physical system, how we are relating like quality education in the COVID scenario. We have seen like digital education is the must scenario for the every student. That was a part of the system, and we are interacting via the Google platform, via the Microsoft platform or Zoom platform. Otherwise we were not able to communicate with each other for the education. Gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry innovation and infrastructure, required inequalities, sustainable cities and communities, responsible consumption and production, climate action, you life below water, life on land, and peace, justice, and strong institution and partnership for the goals. Already, government has started all these like sustainable goals under their schemas. Now we have the traditional society as a like individual layer. I am a person and I am as an individual, and I'm also working in an organization in a like working culture, that is a organizational layer. I'm like going to buy something from the industry is selling out to me the like commercialized project. So that is the industry layer. Now I belong to some community, that is my regional layer. Again, I'm an Indian, that comes under the national layer, and we all are having the globalization as English is adopted as a globalized language. So that comes under the international layer. So this is the traditional society. Now, traditional society is reframed into the Industry 4.0 and Society 4.0 sector. All of us know about the industry 4.0. We have the nine verticals around the augmented reality, blockchain, cybersecurity, cryptography, and machine learning, deep learning. But in society 4.0, what we have done, we have segregated all the governance, technology and innovation, financial services, utilities, art and culture into different various aspects. It may be the history and tradition, religion, health and wellness, science, and in the technology and innovation, we have manufacturing, justice, agriculture, transportation. Financial services, we have tourism, construction, trade, and telecommunication. In utilities, we have entertainment, sports, and athletics. In and military and defense, education and learning. In art and culture, we have the media, environment, and sustainability, and then comes the industry. So, as the definition of the society 4.0, it interest of citizen form the starting point of building the society. Reasons form the basis of the future citizen society as several technological developments enable the decentral production of most primary human necessities from energy and food to health and education. The economics of scale crucial for mass production because now the population is very large. If I'm talking about the Indian context, we have the large population. Okay, so this is a really a challenge that how we can have the production at the mass scale. So we have to relate the industrial society for the mass production become less relevant and therefore also in the future society. The foundations of our future society need to be rebuilt from the basic needs for citizens. Cooperation Society 4.0 supports initiatives that help the rebuilding of reasons by inspiration, knowledge is exchange, networking, expertise, action plans, and concrete solution, if possible, financial support. So, there are 12 project categories under the systematic approach of Society 4.0 that comes new narratives, cleaning the biosphere, and other things. Now, simply, what is AI? We all know the AI is the ability of computer to perform tasks commonly associated with intelligent beings. And what is a machine learning? This is the sub branch of AI where we are having the study of algorithms that learn from examples and the experience instead of relying on hard coded rules and make predictions on new data. So this is when I'm tutoring the small student who is LKG, UKG or first grade student, that comes under the example of machine learning. Whatever you are telling them, they are just learning. Okay, but when we are talking about the new knowledge or new aspects, then it comes under the deep learning aspect because deep learning is a subfield of machine learning focusing on learning data representation as successive layers of increasingly meaningful representation. So we have the successive layers of the meaningful representation in deep learning. So in AI was started in 1950s and it was till 1980s. After 1980s, we are working till 2010 in the machine learning. Now machine learning has another sub branch as the deep learning. So deep learning breakthroughs drive AI boom, and now we have the AI sub branches like generative AI and other branches. So this was the early optimism was started since 1950s, and now we are having the larger disruptions of different aspects. So this is AI. We can say that our computer is able to mimic the human behavior. Whatever the thinking process of a human can we have seen the example of expert systems. So expert systems are able to mimic the human behavior. Now machine learning is able to learn without explicitly being programmed, and deep learning extracting the patterns from the neural networks, whatever the in the a successive layer of the neurons are giving the output that is able to extract the patterns. Now we have another thing. as a traditional machine learning and deep learning. So in the traditional machine learning, like what I have to identify the feature of a cat. Okay, so cat or dog, you will say they will have two eyes and nose. So this is a learned classifier, and it is detecting as a cat. But when we are working on the deep learning, we have learned the low level features, then learned mid level features, so that how many what kind of ears does the cat have, learn high level feature, what kind of face it may have, oval face or another face. And now my classifier has learned to detect the cat. So this is the deep learning aspect. Now, in the society 4.0, we have the foundation of our future society need to be rebuilt and from the basic needs of the citizens. So this is the application of machine learning, like what medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, email spam and malware filtering, self-driving cars, product recommendations, traffic prediction, speech recognition, image recognition. So, when we are talking about AI, so it creates knowledge, and that like machine learning that is given by the Simon. So, changes in a system that enables to do the same task or task done from the same population more efficiently and more effectively for the next time. So, there are two ways where we can improve the system: by acquiring new knowledge, so that is the new facts and the new skills, or by adapting its behavior, means solving the problems more accurately or solving the problems more efficiently. So we are working um, by the learning the process by which a system improves performance from experience. Like what I know the English, that's why I know the how to frame the language, how to frame the words, and how to speak. What is the task? That is a classification, categorization, clustering, problem solving, planning, control, prediction, and others. Now, why study machine learning? Developing better computing system. So whenever developing a system is very much too expensive to construct manually, because they require specific detailed skills or knowledge done tuned to a specific task, that is knowledge engineering bottleneck. And we have to develop the system that can automatically adapt and customize themselves to individual users, that is the personalization, news or mail filter, personalized tutoring, customization. Discover new knowledge from large database, that is a data mining. So we have the market basket analysis in a mall. We have seen the example of market basket analysis, medical text mining. So all these things comes under the machine learning, where we are working for the new knowledge extraction, automatically adaptation of the knowledge, and constructing the knowledge automatically. So these are the related discipline where we can implement the AI. So AI itself, data mining, probability and statistics, information theory, numerical optimization, computational complexity theory, control theory, psychological development, and cognitive thinking, neurobiology and linguistics, and philosophy. So now, what is the difference between human and the machine learning? We have the cognitive science versus the computational science. Okay, so if animal is wants to learn like birds, animal cannot learn like birds. Okay, yeah, I can say that I cannot fly like birds. Okay, so as a machine, we can make them able to fly like birds. Many ML models are based on human types of learning, evolution versus machine learning. So we are evolved, like in future generation, what will be the height, what will be the structure of the human person. And in machine learning, it is a continuous process of learning. There is no such kind of evolution. It may be revolution, but it is not evolved, like Darwin's theory. Designing a learning system, when we are working in a learning system, we have to choose the training experience, choose exactly what is to be learned. That is my target function. That will be my target function, that whatever the system I am going to develop, it must learn this thing. That is my target function. Choose how to represent the target function, choose a learning algorithm to infer the target function from the experience. Now we have the environmental experience, we have the learner, knowledge, performance, and limit. Okay, so In 1950s, Samuel started with the checker player and selfish pandemonium. In 1960s, machine learning is started with the perceptron and neural networks and the back propagating algorithms, pattern recognition, learning in the limit theory, Minsky and Pepper prove limitation of perceptrons. 1970s, we have the symbolic concept induction, instance each learner, expert system and the knowledge acquisition bottleneck, Cullen ID3 and Michalski AQ and Soyabin are diagnosis, scientific discovery with Bacon and the mathematical discovery with AIM. In 1980s, it came with the advanced decision tree and the rule learning. And after that, it was the explanation based learning, learning and planning and problem solving, utility problem, analogy, cognitive architectures, resurgence of neural network mechanism, and break propagation. Am I audible now?
Yes, ma'am, you're audible.
Okay, thank you. So in 1980s, we started with the cognitive architectures too, and another thing was like resurgence of the neural network. We have in 1980s as a data mining, and as the like current generation, students are able to learn the machine learning as well as the deep learning as a subject. At the time of our era, we were working on the data mining, okay, reinforcement learning, inductive logic programming, where we have the prologue and other things, ensembles, bagging, boosting, and the stacking based networking. In 2000s, it was started with the support vector machine, kernel methods, graphical methods, statistical, relational learning, transfer learning, sequence labeling, and other computer system application, email management, and personalized assistant that will learn and learning in robotics and the vision. So these are like data sets for data mining. Now we like in ML in real life, what we have like we are able to see the Netflix. Okay, so Netflix we are giving Netflix is giving the suggestion with my experience. Okay, if I am very much fond of watching horror movies or watching detective series, okay, it will predict which kind of search history I have and will suggest with my current trends whatever the thing I have seen and what can I see. Okay, another thing, like if I just log in some kind of a challenge competition and I'm just googling all those histories, yes, whether there is a coding competition related to Python, or where like just give me the websites where we can contribute for the open source community, okay, open source tool. So another time whenever I'm going to search, then it will be giving me the like predictions and the analytic, so that you can just search out this Google competition or another competition in Facebook, like whatever the friend list you have, another kind of like ML process that you will be like see that what kind of friend you can add in your friend list, there will be the friend suggestion. So, in the machine learning as a process, we have to define the objectives. It may be measurable and quantifiable goals, and use these stages to learn about the problem. We have the data preparation where we are normalization, transformation, and missing values, and the outliers analysis. Then we have the model building that where we are working in the data splitting, feature engineering, estimating performance, evaluation, and the model, and selection where we are applying our model like CNN architecture, unit architecture, and whatever the architecture you have. Then we have the study models accuracy, that is my model evaluation. After that, we have the model deployment. So that is like ML is a process where we are working on the model evaluation. Like in the breast cancer, when we are working on the diagnosing of the cancer, it is not that much easy. What we are working generally in the research papers. So what kind of feature, like if I'm just talking about the cancer, so cancer has several categories. Okay, so broadly we have two categories, like benign cancer or the metastasis or melan cancers. Okay, so what kind of cells you are predicting, whether it is just existing cell, or it is creating by the evolution of other cells. So features we have to predict, then we have to diagnosis with my algorithm, then we are going to prognose and kit. So we have to differentiate, yes, so this is a benign cancer, or high metastasis malignant cancer. So this is whatever the images you have, so each cell is having the certain features to detect the certain boundaries. So whether you are applying support vector machine reinforcement learning, it must detect the accurate cells for the tumor. So this is if we have the green and the red dashes. So we have the main texture area, worst area, and the worst smoothness. Okay. So in the underlying structure, we have, yes, this is the okay types of cells, and another cells are um, like uh, having the category of the cancer diagnosis. So another revolution is the robotics, that is chief robots, chief sensors, and we are following the Moore's laws. So they are serving in the industries, serving in the military, government, and the space robots. We have service robots for home, healthcare, and laboratory. We have vacuum cleaner robot also nowadays. Another thing, robot are used in the dangerous task. Like we have the Kedarnath flood, okay, and tsunamis, okay. So if we are building some kind of robot that can work in that hazardous situations, that will be the social aspect. Another term is the control technologies, that is autonomous, self-control, teleoperated, remote control car. We have the robotic cars and other. In the industrial robot, like uh, we have the welding, painting, cutting, dispensing, assembling. These tasks are very tedious for the human labor. So for these all tasks, we are developing the industrial robots. So this is automotive, and we have the packaging. So this is how industrial robots are going working automotive. We have the military robot as a robotic andros and the eye robot who will detect the another robot is that it will go inside. I can say it is a drone, no, neither robot. In Afghanistan, they are training their soldiers by robot, with the help of robot, that how to defuse a landmine using a padbot. Okay, so this is the robotic application in military. Another is the aerial drones, where we are working for the military application. So another drone, it is recently developed by the engineers, that it will detect the if we are floating that drone into a building, that will detect a target who are handing the guns in their hands, and automatically shoot the person. So that is the drones for the military. Just a minute. Hello, am I audible?
Yes, yes, ma'am.
Yes, sir. So sorry, due to our NB visit, I have to leave right now. Uh,
Oh,
yeah.
okay. So you're right away leaving right now.
Yes, yes, yes. I have to go. There is my call.
Okay,
Yeah, I'm
that's
really
okay.
sorry. Yeah, but it was
If
almost.
you share your email ID on the chat, we'll send you if there is any question regarding
Sure,
the
sure.
presentation.
Right.
Okay, ma'am. Thank you. Thank you.
Okay. Thank you so much, sir. Thank you, and sorry because it was like tedious to have all these things together.
That is okay, ma'am. Thank you for
Thank you so much, sir.
giving your time.
Yeah.
Hello. Hello. Excuse me. Do we have a presenter in the name of GS College Jabalpur? Uh, yes, sir. I have made you co-host. You can even turn on your camera if you want.
So my name is Anurag Upadhyay, sir, from GS College.
Yes, sir. Yes, sir.
I just
Okay. Okay. Fine. You are the attendee because we are waiting for a presenter as well.
okay.
That's okay. Okay. Thank you. Welcome, sir. Ratnesh, sir, can you hear me?
Yes, sir.
Yeah. If you are ready, we can start your presentation.
Yes, sir. Yes,
I,
sir.
I have made you co-host. You can turn on your camera and
Yes, sir.
you can start. Yes, sir. We can see you.
Okay. Thank you, sir.
Okay, sir. You can see the presentation sharing button. You can
Yeah,
start
yeah. Yes, sir.
whenever you are ready. Okay. Okay.
Sir, is my presentation is visible?
Not yet, sir. Maybe it's loading. Yeah, yeah. It has come now.
Okay. Thank you so much, sir. Good afternoon to one and all present over here. My presentation topic is comparative study of neural network model for prediction of chaotic system. I'm a research scholar of MATS University, Raipur. And in the next slide, the contents is showing here. The first one is introduction, second is literature review, and third one is research problem, research gaps, or problem statement.
Sir, sorry to interrupt. Can you put it in presentation mode? It will be visible better.
Okay, okay, sir. Just a minute, sir. Sir, is second slide is visible, sir?
No, actually, sir, maybe you have shared just the window, so
Yeah,
that's why your
just a minute,
presentation
sir.
is not shown yet. Yeah, so
Yes, just a minute, sir. Just a minute. Kindly check, sir. Hello.
yes, sir. Sir, it's visible. Can you
Yes,
put
sir.
it in presentation mode? Then I'll tell you whether it's visible or not.
Okay, okay, sir.
Yes, sir. Perfectly. It's visible
Okay.
now.
Good afternoon, one and all present over here. My presentation topic is comparative study of neural network models for prediction of chaotic system. I'm a research scholar of MATS University, Raipur, Chhattisgarh. So in the second slide, the contents is showing here. Introduction. First one is introduction. Second is literature review. Third is research problem or research gaps or problem statement. Fourth one is materials and methodology. Fifth, research analysis and research comparison. Sixth is conclusion. And the last is list of references. In introduction, in order to anticipate chaotic system in context of climatology, I have conducted an analytical study of neural network model in this research paper. Here I reviewed the study that has been done on this topic by researcher. I will go some of the key points, background mentioned above in the opening section. I have divided this introduction into three parts. First one is climatology. So everyone want to know what is climatology. So climatology is the study of atmosphere and weather patterns over time. This field of science focuses on recording and analyzing weather patterns throughout the world and understanding the atmospheric condition that causes them. It is sometimes confused with meteorology, which is the study of weather and weather forecasting. However, climatology is mainly focused as the natural and artificial forces that influences long-term weather patterns. The second one is butterfly effect. This one is another important concept uh, in terms of climatology. The butterfly effect is an underlying aspect of chaos. It explains how a small fluctuation in one condition of a non-linear deterministic system can generate a huge difference in the later outcomes. It means that there is a delicate dependence on beginning state. All nonlinear systems behave in a chaos manner in which a small change in one condition can lead to a huge variation in another condition. The third part is in the introduction slide is prediction methods in neural network. There are many prediction methods available in neural network, and I have listed some of them here. Some useful prediction methods are BPN, NFIS, RNN, ARIMA model, ANN. I have studied here. In the next slide, in the literature review, I have reviewed many research paper, and I some of them I have presented here in tabular form. The first, and in the table one, I have presented climatological data analysis of BPN model. So some authors and classification methods and results are showing here. Misra et al. In 2018 used feed-forward neural network. They used two models, M1 model and M2 model, and they found M1 model is better than M2 model for 1 month ahead forecasting. Similarly, Saxena et al. In 2013 used BPN and MLP, and they found 94.28% accuracy. Similarly, Singh et al. In 2016 used BPN model, and they found better accuracy. In the second part of a table, I use a ARIMA model for climatological data analysis. Here, Golosky and Agee use ARIMA model and found good accuracy. Al-Hasmi et al. In 2014 uses ARIMA and MLR and found good accuracy. So there are many authors here, but I'm describing only some of them. Sukla et al. In 2014 used ARIMA, and uh, and the result is temperature and humidity forecasting is approximately 94%. In the next slide, I used a ANFIS model for climatological data analysis. Here, Naika et al. In 2019 used ANFIS model and found good accuracy. Matri and Tiwari use ANFIS, ANN, and BNN model, and combination of these model, they found better accuracy by ANFIS model. Similarly, in just a minute, in table 4, author Wu and Chow uses ARIMA, KNN, ANN, and MANN model, and they found better accuracy by MNN model. Chattopadhyay et al. Uses GFNN, MLP, and MNN model, and they found the result good accuracy by MNN model at least 89%. Kumar et al. In 2016 used FN, feed forward neural network, and he found good accuracy. So these all authors work in the same field and found the better results, and I have presented only some of them. The next slide is research problem or problem statement. As we know, the prediction of internal dynamics of chaotic system is an important area of research. So the question is that what is internal dynamics? As we know, weather and climates have a profound influence on life on Earth. They are the part of daily experience of human beings and are essential for health, food production, and well-being. climate data are non-linear in nature, internal dynamics of climate data is always an important area of research. Climate has many factors like wind speed, minimum temperature, maximum temperature, humidity, precipitation, etc. These all factors are changed invariably. The dynamics of these variables is difficult to predict. So we have to identify. So I present my research paper for especially in this field. So far there have been many studies in the on the simulation and prediction of chaotic system using numerical simulation methods, and other methods have been performed. However, there are many intractable problems in predicting chaotic system using numerical systems, such as initial value sensitivity or error accumulation and unreasonable parameterization of physical process. In this study, I have studied lot of neural network model. The present literature review has given assurance to use neural network as a strong tool to predict internal dynamics of climatological data. In the next slide, materials and methodology. The material and methodologies for carrying out this research I have used listed below. First one is literature review. Second is data collection and pre-processing. Third is feature selection and extraction. Fourth is chaotic system identification. And fifth is comparative analysis. So literature review, I have already gone through this part. Data collection, I have collected similar data from different sources. Feature selection, I have used wavelet transform and other methods. Chaotic system identification, for I have used a neurofuzzy model and different kind of things for identification of this thing. And for comparative analysis, in this part I have used BPN and other different neural network models for the fulfilling of this purpose. Research and result and analysis, or a result and comparison. So as we know, in the previous slide, the majority of researchers who have used neural network techniques for forecasting various weather phenomena have used the same architecture as was discovered after reviewing a large number of architectures for prediction of internal dynamics. I have studied at least 21 years research paper, and the vast majority of weather expert agreed that BPN, RVFN, ARIMA, NFIS, and MLP are the best technique for making accurate forecast. In order to forecast the internal dynamics of a chaotic system, ANN can be applied to climate data because it is dynamic and non-linear. Overall, it has been seen that while comparing other prediction techniques such as statistical or a numerical modeling over meteorological data, I found neural network is the best one to predict weather forecast or chaotic behavior. In the table 1, 2, 3, and 4, and in figure here in figure, as you can see comparative analysis. BPN, I have studied that BPN model is well suited for the accuracy of forecasting or chaotic data. Conclusion. In the next slide of conclusion, the strength of ANN are primary focus of this research. It works well enough to detect chaotic motion in non-linear data time series. The research has an advantage since it confirms that ANN is well suiting for identifying internal dynamics of highly dynamic non-linear systems and making prediction about them. For a comprehensive analysis, neural network architecture in practice, we know that BPN, RVFN, ARIMA, NFIS, and MLP are the approaches most commonly used by researchers, with the test result deemed sufficient and absent of rebuttal from the scientific community. In general, it has been seen that out of many prediction models available, including statistical, numerical modeling over meteorological data, I think neural network have proven the most effective. And the list of references, actually I have studied over 150 papers, but in for preparing this paper, I have used only 25 research paper, and these 25 research paper are shown in next three upcoming slides. And thank you so much, sir.
Thank you, Ratnesh, sir.
Ji, thank you, sir.
Do we have any questions and any doubts among our audiences? Ratnesh, sir, it was an interesting topic. I have some queries I have because I'm new to this topic.
Yeah,
I just wanted to know BPN, ANFIS, ARIMA, are these neural network models?
yes, sir.
They are all deep learning, right?
Yes, sir. They all
So,
different.
have you used any one of them, and have you seen that, for example, nowadays, because of various El Nino effects and all, our climate has become very unpredictable. So,
Yeah.
is there any data available, data set available of India where we can predict that in Rajasthan whether it's going to be like
Yeah.
flood or something like that?
Yes, sir. Because we have IMD. Actually, in my research, I used a data set from IMD Pune, and this data set is easily available from IMD Pune, and many secondary data is also available. But in authentications point of view, I use a data set from IMD Pune.
And what is the size of IMD Pune corpus?
Yes, sir.
What is the size of IMD Pune dataset?
Actually, sir, I used at least 25 years data.
Okay.
25 years back data I have used, because my research guide also uses the same, and he uses at least 2000 to 2022 data, but I have gone through 2023 and back to 1987. So this data set I have used, sir.
So for people, those who are listening, for them, those who want to take up this as a challenge or as a topic for their research, do you recommend that? Is there any scope of making a new model, like combination or a better thing out of these all that you told?
Definitely, sir. This is a very interesting topic, and I have also very much interest, because I am using in my research area, I am using neurofuzzy model, and neurofuzzy, because statistical and numerical modeling is not sufficient to predict the behavior of chaotic system or weather forecasting in such kind of scenario. So I am using neurofuzzy model, and I recommend everyone to go and do the research in the same field.
Anybody else has any doubts, any questions? Okay. Okay, I think Ratnesh said there's no doubts among people. But your topic was really new because nobody else has given a paper in this journal in our conference regarding this topic. So
Yeah.
we have your contact. If somebody of our research scholars want to do something, take up and need your guidance, will definitely.
Sure, sir. Sure. Most
Thank
welcome,
you.
sir. Thank you so much,
Thank
sir.
you, sir. So everybody, we have now a little break in this online session. We will again continue this at 3 o'clock whenever another keynote speaker will be with us. Okay, thank you.